This class we are going to discuss about GSM architecture. European group began to develop this GSM structure in June 1982 with two main objectives. The first one is the pan-European roaming, which offers compatibility throughout the European continent. And the second one is the interaction with the integrated service digital network, which offers the capability to extend the single subscriber line system to a multi-service system. So, in this initial development of GSM, it is not a big issue within system capacity, but later on, the system capacity makes a big issue as the rapid growth of cellular service has been increased. So after that, it has been 35 revisions has been made to this GSM since the first issued specification. And the first commercial GSM system is named as D2 and is implemented in 1992. And the this what you're looking is nothing but a GSM architecture, external environment of BSS. So in this GSM architecture, we are going to have MS as you're looking at BSS, NSS, and OSS. MSS is abbreviated as mobile station, and BSS is abbreviated as base station subsystem, and NSS as network switching subsystem. So the now we are going to look at each and individual one. So now in this mobile station, first of all, this mobile station includes two components. The first one is mobile equipment, is nothing but ME, and the subscriber identity module. It's nothing but your SIM. So ME does not need to be personally assigned to one subscriber. The SIM, and whereas SIM, nothing but SIM, is a subscriber module which stores all the subscriber related information. When a subscriber information is inserted into the ME or mobile equipment of an MS, that mobile station belongs to the subscriber and the call is delivered to the particular mobile station. And ME is not associated with a call number, but it is linked to the SIM. And the next one is nothing but your BSS. Now we are going to look at the base station subsystem. Basically, the BSS connects to the mobile station throughout a radio interface. Okay, so and all these interfaces we're going to talk later. So first of all, yes, here, yes, the BSS consists of a base transceiver, nothing but BTS, we are going to call it as an BTS, and located at the antenna site. And whereas base station controller that may control several BTSs. The BTSs consists of radio transmission reception equipment similar to the ME in an MS. MS is nothing but a mobile station and ME represents a mobile equipment. And in this particular BSS, we are going to have TRAU, which is abbreviated as transcoder or rate adaptation unit. So what is the use of this TRAU means? It carries out the encoding and speech decoding and rate adaptation for transmitting data. And as a subpart of BTS, the TRAU may be sited away from the BTS, usually at the MS. In this case, a low transmission rate of speech coding channels allows more compressed transmission between the BTS and the TRAU, which is cited in the MSC. So next we are going to look at this NSS, nothing but a network and switching subsystem. A signaling NSS includes the main switching functions of GSM. NSS manages the communication between the GSM users and other telecommunication users. So as you can see here, and this NSS management consists of MSC. MSC means nothing but a mobile service switching center, coordinates call setup to and from GSM users, right? And the next one is interworking function. It's nothing but your IWF. So it is this interworking function will act as a gateway for MSC to interact with external networks for communication with users outside GSM. Outside GSM means you can as it as and pick packet switched public data network or circuit switched public data network. So the role of IWF depends on the type of user data and the network to which it interfaces. And the next one is nothing but your HLR. So here you can see the functional architecture and principal interfaces. So in the next one we can able to see is nothing but your HLR, home location register. So in this home location register, the is a nothing but your standalone computer without switching capabilities, a database which contains subscriber information and information related to the subscriber's current location. It is only about the current location but not the actual location of the subscriber. And also a subdivision of the HLR is nothing but your authentication center. That you can see in the next diagram. So authentication center manages the security data for subscriber authentication. Another subdivision of HLR is nothing but the equipment identity register, which stores the data of mobile equipment or uh, in this we can also see the another one is nothing but your visitor location register. It's nothing but your VLR. Links to one or more MSCs temporarily storing subscription data currently served by its corresponding MSC and holding more detailed data than the HLR. For example, the VLR holds more current subscriber location information than the location information at the HLR. And here we can see about GMSC. So this is the diagram for your internal structure of your NSS. There you can see about BSS is going to pass through an GMSC. In order to set up a requested call, the call is initially routed to a gateway MSC. It's nothing but your GMSC, right? Which finds the correct HLR by knowing the directory number of the GSM subscriber. And the GMSC has an interface with the external network for gatewaying, and the network also operates with the full signaling system. It's nothing but SSM, SS7. So there you can see there we're going to have the double way communication with GMSC to HLR, which operates through a full signaling system, nothing but SS7, and HLR to MSC, and GMSC to MSC or VLR also, right? And through this next we can move on to the operational subsystem. In this operating subsystem mainly we're going to have three functions. In that the first one is the network operation and maintenance functions, and the second one is the subscription management and including charging and billing and mobile equipment management. So all these things will be done by this an operating system subsystem, right? Thank you.